continue from last video. In last video we calculate this reaction force 1.14 kilonewtons coming here. Now if I need to know the shear force due to this dead load, which is 0.76 kilonewtons coming onto the stringers, then we can just take a component in the cos 31. Now the cos 31 is coming from here, 3 meters and 1.8 meters. In our problem we have given this 3 meters and 1.8 meters. That was taken from 12 times 150. In the last video I explained you that 1.8, so that is 1.8 by 3 meters triangles, that is 3 by 1.8. so tan theta is equal to opposite over adjacent. Theta is equal to tan inverse 1.8 will be 31 degree. So that is theta 31 degree. So if I have a 1.14 and that is the incline of 31 degree, so the shear force would be 1.14 cos 31. So that's reaction force times cos 31 component. Take away, let's say we want to calculate the reaction force at the midpoint. So 1.5 that is the half distance times cos 31 times by that weight 0.76 times by that 0.19. 0.19 is coming from here. That's 0.19 is coming from here because we want to calculate the shear force perpendicular to that cross sections. So therefore it gives me 0.8 kilonewton. That is the shear force due to the dead load, 0.76 kilonewton per meter. Now the moment due to the dead load or permanent load is WL square over 8, is a uniformly distributed load. So the bending moment diagram gives us the parabola, and at the midpoint that will be WL square over 8. W would be 0.76, length is 3 meters square over 8 will give us the moment due to the dead load is 0.86 kilonewton meters. Now what about the live load? The example does not say anything about the live load, but we will consider a various scenario. Now the first case number for the imposed actions is case number 1 is taken from AS and ZS 1170.1. If you come back into these tables, in that A classification give the domestic activities, and I think there is house. So in the question is house, so that is domestic activity. In that one we can find the stairs. For the stairs they give you uniformly distributed action is give us 2 kilopascals. So we take it 2 kilopascals. It's saying that your stairs will come up across with 2 kilopascals live load. So 2 kilopascals times by 1.2. so because you can see this 1.2 meters, so the stringers are sitting like that 1.2 apart. From one stringers to another stringers, the stairs has a 1.2 meters given in the question. So if you want to calculate per stringers, let me write the per stringers here. If I want to write the per stringers, so you can just have 1.2 divided by 2, so you have 1.2 kilonewton per meter. That's what the one stringers. So now same scenario that we covered here in the last video, in just last tip we covered this 1.14. so only difference is that UDL load is 0.76. so in that 0.76 we can have 1.2. so 1.2 times 3 that we done, that give us 3.6 kilonewtons. The load that is coming in the middle, that is 1.8. so that is a reaction force 1.8. That divide by 2 gives a reaction force 1.8 at two ends. So it's basically same thing. Reaction force 1.8 times cos 31, take away 1.5, that is the half distance because this is 3 meters, times by 0.19 because we are calculating the reaction force along the perpendicular direction of that surface of that stringers, times 1.2 times cos 31. So 1.2 is that UDL load times cos 31 gives me 1.25 kilonewtons. Now that is the shear force due to the live load, and that is the case number 1, 2 kilopascals. Now if I want to know the bending moments due to this case 1, WL square over 8, same like the one that we calculated here, that gives me 1.2 UDL load times 3 square, that's length 3 square over 8, 1.35 kilonewton meters. Now case number 2, that is 2.7 kilo concentric load. So if you come back here, they will have a 2.7 concentric actions in their standards, 2.7, table 3.1, and stairs domestic activity we can have 2.7 kilonewtons. So it's the standards one. So 2.7, if you like to share within the two percentages, 2.7 divided by 2 give me 1.35 kilonewtons, and 1.35 kilonewtons divided by 2 give me the reaction force, which is 0.675 kilonewtons. And if you do the structure analysis, you will get the shear force due to this live load 0.675 kilonewtons, and the moment due to this live load is WL over 4. 135 times 3 meters is the length, over 4, 1.01 kilonewton meters. Load case number 3. Let's say 2 persons are carrying a refrigerators on their stairs. On these stairs, let's assume there are 2 persons carrying the refrigerator. They are applying the live load. So I just do these 2 persons. Let's say each person is weight 100 kilograms. So 100 times 10 to convert into newtons, divide by 1000 to get it into the kilonewtons. So 1 kilonewtons, they are at 1.5 meter at distance. And if you do the analysis on this one, you will get the shear force 1.29 kilonewtons. You can find the reaction force and shear force, and the bending moment for this kind of loading is 0.75 kilonewton meters. Now design loads is the strength limit states, like a factor load. Shear force is 1.2 dead load plus 1.5 live load. Now 1.2 dead load, the shear force due to the dead load we calculated 0.8 kilonewtons. I substituted here, plus 1.5. Now we have various shear force. Shear force in the load case 1, 1.35, 0.7 0.7 for this case, and we have third one is 1.29. In between you have 1.35 is the maximum, or 1.29 is the maximum one. So 1.29, because 1.25 here for 1, 2 is 0.7 and 1.29 is the maximum. So that's worst case scenario is 1.29. If you substitute, you have shear force 2.9 kilonewtons. Now moments, 1.2 moment due to the dead load plus moment due to the live load. So 1.2 the dead load moments that we calculated 0.86 kilonewton meters plus 1.5. Again you have 3 options, 1.35, 1.01 and 0.75. So in among that 1.35 load case number 1, you have a maximum moment, so you substitute 1.35. it gives me maximum moment 3.06 kilonewton meters. Now the cross sections that we assume should have a capacity, the bending capacity should have a shear and bending capacity should be more than this one. So whatever the cross sections we assume, we will calculate the bending capacity should have this more than 3.06. that we're going to look at in the next videos. Thank you.